you can go ahead and do so. Just let me know. Teacher, can you please go back or something like that, all right? Let's begin. What would be the conjugate? What is the definition? All right. So let's say we have a complex number. Let's say we have the complex number z. Since this is a complex number, z, it is compound of two numbers, two real numbers, a and b, right? This is called the real part and this is called the imaginary part. Just like any other regular complex number, all right? Now, what would be the conjugate? All right. First, the conjugate is denotated, which means this is how you write it down. This is how you write conjugate. We're not going to use the word conjugate anymore. We're going to use this notation, a little line on top of the number. So if the number is z, the little line on top of it means it's conjugate. All right. And it is defined as the same number, but instead of addition, you're going to write subtraction. That is it. That is a conjugate, right? Again, z is a complex number. So if I put a little line on top of it, I am talking about conjugate. Putting a line on top of it means putting a line on top of the whole number. And that, what that means is changing the value of the operation inside the complex number. If it is addition, you're going to write subtraction. If it is subtraction, you're going to write addition. That is it. Every other thing remains the same. If this number is positive, it will continue being positive. If this number is negative, it will continue being negative. The only thing that changes is the operation inside. So the value of b. That's it. Let's look at some examples. Let's look at this one. X is my complex number. The complex number is 3 plus 2i. That is my complex number. Then what will be x conjugate? X with a little line on top. All right. X with a little line on top will be the same number, but now instead of addition, I write subtraction. Everything else is the same. The 3 goes down. The 2 goes down as well. The I goes down as well. The only thing that changed was the operation inside. So the real part remains the same, but the imaginary part changed from 2 to negative 2. All right? The imaginary part is what changes with the conjugate. Let's look at a different example. W is the number negative 7 minus 8i. A regular complex number, right? Okay, so what will be the conjugate of W? Well, it is exactly the same, but the only thing that changes is the imaginary part. Instead of being negative 8, it's now going to be positive 8. Everything else remains the same. That is the idea of a conjugate. It is absolutely simple. So simple that we can do some operations with them. All right, let's take a look at this example. This one is a little bit more interesting example. A little bit more interesting example. All right, z is the usual number that I have over here. Just any regular number. Then what will be the solution of multiplying any complex number with its conjugate? Let's take a look at that. If you multiply these two using FOIL, remember this is a plus bi, and the conjugate will be a minus bi. So if we do this times this, we have to do FOIL, right? So first, right, a times a squared. Outers, so a times negative bi, so negative abi. Did you see? We're doing FOIL. So we did F and O. Let's do I. Inners. BI times A. BI times A. Those are the inners. Okay. ABI. Simple. And then last. So BI times negative BI. BI times negative BI. All right, positive times negative will be negative, and BI times BI is BI squared. All right, Beautiful. We just did the multiplication. This is the regular multiplication for every single number that we have. That is a complex number, of course. All right. We're done. Now what? Can we do something else? Yeah, right? We can do like terms. You guys know that I squared is -1, right? So I squared will be -1. And this -1 with this negative will be positive. So instead of negative b squared, we have positive b squared, which is this over here. The a squared is this one over here. Then what happened with the rest? What happened with these two? Where are they going? Okay, look at this. These are the same number. ABI, ABI. The only thing that changes is the sign. We have negative and here we have positive. So we are subtracting and adding the exact same number. This is 0. This is 0. These two numbers get canceled with one another. Okay? So the solution will just be the a squared and the positive b squared. A squared plus b squared. By multiplying these, we effectively eliminated the imaginary part. There's no longer an I. This doesn't have an I. And this is so strong. Why? Because of the things we're going to look at next. Here are some exercises. We're not going to do these exercises today. This is not a homework. Don't do this, please. Let's continue with division. And now begins the fun part. Conjugates were only a little help for us to be able to divide complex numbers. All right? Conjugates were only a little help to help us divide complex numbers. This is how we divide. Let's say that we have two complex numbers, W and Z. How do we do this? How do we do this division, W over Z? How do we do that division? Again, we are dividing complex numbers because we're saying W and Z are complex numbers. In the future, of course, I'm going to do examples of these. Don't worry. So far, I just want to show you a little bit of mathematics. But in a little bit, 10 minutes, 5 minutes, I'm going to show you a real example, right? What we're going to do is we're going to use the conjugate of Z, of the denominator. Always use the conjugate of the denominator in the division. How are we going to use the conjugate? Simple. We're going to multiply both up and down by the conjugate of the denominator. Remember, W over Z was the operation we want to find. So how do we solve this? We multiply up and down by the conjugate of the denominator. Right? That is the trick. Let's look at some examples. Oh, by the way, this is a 1, right? So this is the reason why we can do this multiplication. Because W over Z is the same as W over Z times 1. Remember, whenever you multiply anything times 1, the solution is always the same, right? It's the same before. So by multiplying by 1, we didn't affect our division. Beautiful. All right, let's begin with some examples. Let's try to do this one over here. 9 divided by 2 minus 3i. Quick question, guys. Is the denominator a complex number or not? In the chat, please. Yes or not. Is the denominator 2 minus 3i, is that a complex number or not? All right. Beautiful. Thank you, guys. I have 6 people answering. Beautiful. Thank you. Yes, it is a complex number, right? We have a real part, 2, and an imaginary part, -3. So it is a complex number. Beautiful. Another question then. What can you say about 9? Is the numerator, so the 9, is it a complex number or not? Write it in the chat, please. Okay, we have one person answering. What happened with the rest? Thank you, Danny. Another person. The first one was Stefa Cabrera. All right. Pretty good. Now some people are answering. 6, 7, 9 people answering. Beautiful. And you guys are correct. You guys are correct. This is also a complex number. We saw this in another class, right? We saw this in another class. Even though this 9 doesn't have an I somewhere, just like this have an I. Even though you cannot see the imaginary part, the 9 has an imaginary part. The imaginary part will be 0. Because you cannot see it, but it is there. This is 9 plus 0i. 9 plus 0i. Okay, so it is there. This is a complex number. So what we're doing here is dividing two complex numbers, right? Beautiful. How do we do this? How do we divide two complex numbers? Solution. Let's begin with the first one, and this can be also explained, can be also written as the same but multiplied by 1. Remember, this is a 1, right? 2 plus 3i over 2 plus 3i. This is the face of an 1. So we are multiplying by 1 here. But the 1, remember as I showed you at the beginning, we're going to multiply up and down by the conjugate of the denominator. This is exactly what we did here. The conjugate will be 2 plus 3i because the number is 2 minus 3i. So that is why we need to know how to find conjugates. We're going to multiply up and down by the conjugate of the denominator. Beautiful. So if we do that multiplication, this is what we're going to have. 9 times 2, 18. 9 times 3i, 27i. And down we just do FOIL. 2 times 2, 4. 2 times 3i, 6i. Negative 3i times 2, negative 6i, right? And negative 3i times positive 3i will be 9. Negative 9i squared, right? This is the usual multiplication of complex numbers. We know how to do this, right? From here, all we can do is try to do like terms in the denominator, right? 6i and negative 6i, these two are going to cancel, just like they did here. The negative and the positive values in the middle, they canceled. And what we have is a squared plus b squared, the first value and the second value squared. This is exactly what we have here. The first value squared, the first value was 2, so we have 4, the first value squared. And then negative 9i squared. This I squared becomes a negative 1, right? That is the idea behind the powers of I, right? This is the definition of our imaginary number, right? So negative 9 times negative 1 will be positive 9. So we have 4 plus 9. The first square plus the second square. We do this addition. 4 plus 9 is 13. And now what we can do is separate the values. We want to be able to know, to find. We want to be able to find the real part and the imaginary part. So we have to split those values. How do we split them? Simple. The denominator is going to be on both the 18 and the 27. Look, it's the same denominator. 13 under the 18 and 13 under the 27. The operation in the middle is going to be the same. Excellent. So from here we can know what is the real part, 18 over 13, and the imaginary part, 27 over 13. This is how you write complex numbers in standard form. In the future, guys, and whenever we do these divisions, you are not going to find divisions of. No, you are going to find, write this number in standard form. That is what the enunciation will say. But you now know how you can do it. You just have to divide and then split the result. That's it. Let's go with another example. B. 1 minus 2i over 4i. This is a division of complex numbers, right? So we are going to do the same approach than here. Solution. Take the number and then multiply it by the conjugate of the denominator. Look, this number has a conjugate. You might be thinking, all right, but how? It doesn't have two numbers. Doesn't have to. Remember that everything else stays the same. And in here, the real part is 0. So, of course, the real part will also be 0. But the thing that changes is the imaginary. The 4, which was positive, is now negative 4. So now we have the conjugate of this one. 4i times negative 4i. And since you multiply down, you're also going to multiply on top of it. Remember, multiply on top and under by the conjugate of the denominator. All right, let's look at the mathematics. 1 times negative 4i will be negative 4i. Negative 2i times negative 4i. Negative and negative positive. Beautiful. 2 times 4, 8. Beautiful. I times I squared. Beautiful. How about this 2 here? 4 times 4 is 16. Positive times negative is negative. And I times I squared. Let's see the chat. Somebody's saying something to me. Yes, Juan Nicolas, you got it, brother. And Maria Salome, tell me. Go ahead and tell me, Maria. Salome. 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 You said you had a question. Salome. Why you multiply by 4i? I didn't multiply by 4i, Salome. I multiplied by negative 4i, right? Why? Because remember, we are going to multiply up and down by the conjugate of the denominator. That's what we did in here. Here, we're doing the same. Look, let's take a look at the first example, A. The conjugate was easy to find. The conjugate of 2 minus 3i was 2 plus 3i. That conjugate is easy, right? We multiply up and down by the conjugate of the denominator. We do the exactly same here, but we need to first find the conjugate of 4i. What would be the conjugate? All right, the conjugate is negative 4i. So we multiply up and down by the conjugate. All right. No. All right. Maria Salome, yes, you say yes. But the definition of conjugate say that is a plus bi. Beautiful. Take a look at this, Maria Salome. This number, 4i, this number 4i is in the form a plus bi. It is in that form. It is in that form because the value of a is 0. Look, here we have 0 plus 4i. That is why the 0 doesn't appear, because it is 0 plus 4i. 0 plus whatever is the same whatever. So you don't write it down. It is a waste of time, but it is there. So what would be the conjugate of 0 plus 4i? What would be the conjugate of this? The conjugate of 0 plus 4i. Remember, the line means conjugate. So what would be the conjugate, Salome? Go ahead and write it in the chat, please. Zero. Since here we have a plus, we have a minus 4i. Did you see? Again, this is how you do conjugates. The conjugate of any number, a plus bi, the conjugate will be a minus bi. In other words, just change the symbol in the middle. Here, the symbol is positive, so the conjugate is negative. That's it. All right? Now, 0 minus whatever is exactly that minus whatever. So in other words, we don't have to write the 0. That is why the conjugate of 4i is negative 4i. The conjugate of 4i is negative 4i. All right? I just didn't do all this process because, come on, it's just finding a conjugate. But it's that, all right? It is that. Beautiful. Thank you for your question, Maria Salome, and you're saying you understood. Thank you. You understood, so I can continue. Beautiful. All right, let's take a look at the presentation again. All right. So again, we multiplied up and down by the conjugate, and this is the result, right? Now, from here, all we do is doing algebra. All we have to do is algebra. So this this I squared becomes a -1, right? And this I squared in the denominator also becomes a -1. Look, this, right? So now we can do the operations. +8 times -1 is -8. And -16 times -1 is +16. Look at that. We are now kinda in this form over here. The only difference is that now we have the imaginary part in front and the real part at the end. So we can change that. All we have to do is put a little order. Look, that's what I did. The -8 in the front and the -4i at the end. All right. This is just to be organized. The real part goes goes at the beginning, sorry, and the imaginary part goes at the end. From here, we're just going to do the exactly same that we did in here. We can split these values. The 16 will go with the -8 and will also go with the -4. Remember, the operation inside or the operation in the middle, in between the fractions, is the operation between the complex number. So we have minus over here. Don't go ahead and say negative -4, negative and negative. That would be a mistake, right? Beautiful. From here, we can see what is the real part and what is the imaginary part. The real part would be this one, -8/16, and the imaginary part will be -4/16. But these two can be simplified, huh? If we can simplify it, we must simplify. So we have -1/2 minus 1/4. And this will be our standard form. The real part and the imaginary part. Beautiful. This is how you write a standard form with two complex numbers. Now, these are the easiest. I'm going to do a little bit harder one. All right. Let's do it. We're going to go a little bit faster this time. We have two complex numbers, and we are going to write them in standard form. In other words, divide. Solution. Again, take the number and multiply up and down by the conjugate of the denominator. The denominator is 5 minus 12i, so the conjugate will be 5 plus 12i. So we multiply up and down by 4 plus 12i. Sorry, 5 plus 12i. From here, do the mathematics. We have mathematics on top and mathematics down. Look, I am even jumping in the denominator. I don't have to do FOIL anymore. Why? Because if you guys remember, the multiplication of a number by its conjugate is going to be the first number. This was 25, sorry. The first number squared and the second number squared as well. This is 25, sorry. This is 25. This should be a 25, all right? So I don't have to do FOIL. On top, I have to do FOIL. 1 times 5, 5. 1 times 12, 12i, right? 4i times 5, 20i. 4i times 12i, 48i squared. In the numerator, I do have to do FOIL. But in the denominator, I don't. All I have to do is do the first term square, 25, and the second term square, 144. Always positive. Let's continue. This will be 169 here. 25, right? 25 plus 144, 169. This is a 25, all right? And if you do this operation, you will have -43 plus 32i. Split the values, and we have our solution. Just like that. Another one. Now with a negative on top. Again, take the same number and multiply up and down by the conjugate of the denominator. The conjugate of the denominator will be 4 plus 3i. 4 plus 3i on top, 4 plus 3i down. From here, just do the operations. So multiply on the numerator and multiply on the denominator. Here. The multiplication in the denominator will be 16 plus 9. Again, if you wanted, you can do the FOIL, but it will give you this. So it is a little shortcut. The first element squared 4 squared is 16. And then the second element squared. 3 squared is 9. Always positive. So 16 plus 9. That's it. Do the operations that you have to do, and we have 16 minus 6i over 25. Split for the final solution, and there we go. We have the answer. 17 over 25, the real part, and negative 6 over 25, the imaginary part. Just like that, guys. Just like that. We finished our presentation of learning how to divide complex numbers. But nothing in mathematics is really learned unless you practice, right? So what I want you to do, guys, is to go ahead and go to Alex. And in Alex, locate the classwork number 3, right? You have all the way until 12 o'clock. At 12 o'clock, the class will be finished and also the classwork. All right, guys? Remember, you don't have to be here if you don't want to. But I am going to be here. I'm just going to mute the mic. I'm going to be here. And if you guys have any questions, you can always ask me. I'll do the exercise in the board, and everybody who's here can see it and maybe learn something about it, all right? But if you don't want to be here because you want to go ahead and do the exercises alone because you don't want to be disturbed, that is okay. You can do so as well, all right? Thank you, guys, and see you at 12. At 12, guys, you do have to come here to say goodbye to me, all right? At 12, you do have to come, all right? See you at 12, guys. Bye-bye.